understanding of the mathematics and the introductions. Then we were like that example is about that what the example that I am skipping now for the moment. We can do it next week. Our Mahala, we have only 2 lectures left and then we will be done with it, right? So the example that I am leaving it now for the moment, it is about the minimum energy, right? The particles should have so that they do not stick to each other in 24 hours. Minimum energy free. The particles by medium kilo or certain group university. The unplanned particles. That's why energy sarvada interaction energy sapakal. Sita spau risk ki each thing you will survive separate from the parts. These are our form. Right? Okay, now we are going to extend our understanding to a molecule, the interaction energy between a molecule, right, and a surface. The surface there is made of similar molecules. What, like, we have one molecule of this, and there is a surface like this. So what should be the force between? Right? So the strategy would be to find the force between 2 molecules. One molecule is this and another molecule is that here, that's contained here. And we integrate it on the surface. So we will do assumption, right? The interaction energy between a molecule for simplicity. That is the topic, right? So we assume that the forces are the interaction is assumptions, right? Attractive, right? They are, the forces are additive and they are, the interaction is additive. They can be added together. Okay. So suppose we have a surface like this, it extends by these curved sides, I mean that they extend, right? Okay, so we have to find, there is the molecule is here, right? And the surface is here. Okay, let this axis, this is x-axis, and this is y, and this is z. X, y, and the right hand system, right? Okay, so we want to find the interaction between this molecule and this surface, for example, this whole surface. So we consider, for simplicity, a simple ring on the surface, and then integrate the interaction energy toward that whole surface. So first we want to find the interaction between a small ring, which is part of their surface, and this molecule. Right? Okay. Let this distance between that is z is equal to d. This is d. We call this distance is. So we consider right here is z equal to 0. The origin is this. The origin is on the molecule. Right? So here this will be z will here will be equal to d. Right? Z is equal to d at this point. Right? Okay. So consider a small ring. Look, this is a surface and I have cut it. So I can see this end of the half ring and this end of the half ring. The ring yapılmışlar şurada sonra verecek kardeşim. Clear? Okay. So this is x. The distance from the central point along the x-axis of the ring is x, and this small height is dx, and this small width or length is dz. Right? So I want to find the volume of the ring first. So I will find the circumference.
Yes, sir.
Right? 2 pi r. The circumference, right? And then multiplying it with dx and dz, that will give the whole volume of the ring. Right? So I can say that the volume, right, of the volume of the ring is equal to 2 pi, right, x dx and dz, right? As we assume that these are the interaction between the molecule
The surface.
and the surface, we said they are attracted. The nature of the interaction is attractive. So I represent it by this minus c for r to the power n. Here we don't know what is the type of forces or interaction because here r to the power n. We don't know long range, short range, whatever. This is general formula. Right? Okay. Now the interaction energy, right? If I say rho is the number density, right? I said rho is the number density. I can say that per watt, right? That is the number density. So the interaction energy between this molecule and this whole ring, there are how many molecules, right? That will be like n is equal to rho. I suppose that is dV. Right? In this ring, there will be this much number of molecules, right? So the interaction energy between this small this molecule, suppose we write it like this, d omega, RG double, right? That will be equal to 2 pi, right? X, dx, and that is the dV volume
Into the
and rho, so number, and multiplied by the interaction energy between a single molecule. This is not multiplication, I will write. Say that. If this is equation number 2, then we can write it like minus 2 pi x, right? And dx dz rho and c over r to the power n. We put the value of the image, right? So if we want to get the interaction between this molecule and the whole surface, we have to integrate over this ring. So, right? So the total, right, which is at look, if d is the distance here, so I can write like this double r will be what? The z squared plus x squared to the power 1 over 2. That's will be r plus.
yes, sir. Beta was to.
Yeah, any r. So I can now integrate this, right? So it's equal to minus 2 pi, right? C constant and rho constant, right? And from z equal to d, from z is equal to d. D? No. Z equal to d, from z is equal to d.
Infinity.
Yeah, because we will see like how can we simplify, okay? So from z is equal to infinity, and there will be x, dx, and 2dz. We integrate over that value to the power n, right? Minus 2 pi c rho and
So that 2 pi r na 2 pi x.
what?
That's from the circumference mga was 2
2
pi
pi c equal 2 pi
2 pi r.
No,
The x.
no. This is the volume of the ring, right? This is the volume of the ring. So we can extend this like this. R is made of z squared plus x squared.
Yes, sir.
We have to change it to the form x, y, z. So that the r plus 0 between the value will go. For here, the integration is on the volume. R R की व्यापक से g square plus x square पर value है So first, that is this was the ring. And if you want to integrate over the volume बड़ा से integrate के लिए करें, expand के बड़ा से करें, तो बड़ा वाले उधर बदल तो भी उधर शंदा बड़ा से उधर शंदा you cannot. That is r, and r is, we have to simplify it to z square plus in the form of z and x. R is the same way. Without going to the goal. And instead of the volume integrate ko kara. The volume for this and the volume is not that it should be.
Sir पहिला माने पेन शुरू से दा x मुंगा वाले वाश तो
Come.
दा x z हम वाले वाश तो y वाले वाश
Come say
delta
the volume was the
ah जी yes sir दा
2 pi. 2 pi x today.
जी जी
That circumference show करना उधर पर की volume फोड़ा करना. When 2 pi x today, that's it. Circular show करना volume पर की बात पर 2 pi x कराना तो
yes sir सही
वो that's it. The goal that 2 pi x today the roof circumference है.
Yes,
The volume पर की बात पर लगा.
सही
The 3 dimension और 2 dimension का वाला خبرها بس أنا
صحيح صحيح.
So circle سواء x g x d z, right? And r to the power n we write z square plus x square to the power n over 2.
Yes sir.
Right? So by simplifying this integral with the help of like partial fractions of these things, right? Treating z equal to constant, suppose at one time. So double. This is integral over two variables. So integral over one variable and then integral over the second variable. The second variable x will be integral to the z constant.
Yes sir.
So here, now our weights will go from minus 2 pi c per rho, now n minus 2, right? Z is equal to d and infinity, right? dz by z is equal z dz to the power n minus 2. By simplifying this, we are left with dz only. Well, x dx over that's the possible. Then we evaluate so we got this n minus 2 landing. Oh, that the answer of z to power n minus 2, right? Just this can be done with partial fraction. This is x over s. Do what x dx over d square plus x to power n over 2. Dog, yeah. That is the number of now putting the limits, right? So when we put the limits, we will minus 2 by c rho or n minus 2 n minus 6, right? And d to the power n minus 3. That is the interaction between a molecule and a surface, where surface is at a distance of d from the molecule, right? Okay, this plan is equation number 4, right? So 4 we consider there are van der Waals forces. So for van der Waals N is equal to 6.
Yes.
Right? So W will be equal to minus 2 by C rho, where rho is the number density, the amount of molecules per unit volume. And here it will be 6 d cubed. For van der Waals forces, the van der Waals forces in a single molecule and a whole surface of the similar molecule. कसु बोले क्या ना? देख बोले R बार भी अलग रहती है, सिर्फ surface characterization की. You know what I'm saying?
Yes sir.
आप जिसको प्राप्त दिया गया इसका रूपी कारण. Interesting खबर मुझे बताओ बेटा करा?
Yes sir. बिल्कुल internal list है.
ना तो भी कोई नहीं दिया.
तो surface खबर है.
बस खबर तो Z is equal to D करा.
Yes sir.
अनोट की ससरा negligible होता. I ना दूर contribution निस्ता. total contribution for surface to surface.
मतलब دا وال دی وال کې درنه کوم
No, no,
پارټیکل
سره ستاسو دا پارټیکل دی او دا وال دی. دا پارټیکل چې دنه بیا هغه بلا سوره ده نو هغه انټریکشن ډیر کم دی د دې سوره چې
دا وال دی
wall او د surface مینس کې دی. هغه نور بیا میټر پی نه دی. موږ چې نو سمپلیفای کوو دا هغه کنټریبیوشن موږ چې دا ډیر راځي. Okay, a force from here, right? So, school minus or W by G, minus 5C rho over 2D to the power 4. So, the force between M R equal
बरो 2
कम से कि सब आती है क्वेश्चन नंबर 5 हां देखिए हां ये वाला 2 बड़ा जितना 2 खत्म ही जल कहां चले 2 खत्म कर से ना दल तना dan de kunt voor dat er dal तना या दल तक 6G की वैल्यू देखा yes I think we forgot. So when we put n equal to 2, it goes up. Now we want to do another situation, right? The interaction between not a single molecule, but a sphere of critical particle of some molecules, like 1 billion molecules or something like that. A small spherical particle. Particle means a lot of molecules there. So spherical surface and a planar surface. The interaction energy between a spherical surface and we should keep in mind that in our situation we consider that all these two materials, they are made of the same type of molecules. That's it. Okay, so spherical surface and planar surface. Remember, these are generally for energy for R to the power n and n could be like whatever they are. Right? So for one of our forces we put n is equal to
6
we can find that which. Okay. So we have a sphere. Suppose that is x. Right? That is 3. Right? Okay. And then we have a sphere over here. That is the sphere. And this is what? There are two planar surfaces. Gamma cut to us, the continuity extends. Right? So the surface is the sphere is of radius, some radius r. Right? And this situation here, surface there today. Now the 0 the z equal to 0. Now the z equal to 0 there. Our separation become the d. So separation between the surface and the sphere, this side of the sphere is d. Say down. Now again, let us consider a ring. So a ring is like this, right? That is x-axis, right? And look, this radius is r. The radius is r. So this distance, this is the correct. That will be 2r minus z. The 2r should.
Yes, sir.
Oh, that's the issue. Z should. That's it. That was the 2r should, right? And here comes z. Right? So look, it will be like this. Simplifying the situation. We look at does it equal or they not, so that we want to simplify things a little, like how to calculate the whole volume and the interaction between this and this line. So does it after we want to do some simplification, right? X varies from here. X not very big, but is equal to the x. The ring does actually for x distance only. Really?
Yes, sir.
So we are playing with 2 degrees. Y is, we did not take y because y we will include y in the circumference. So we will reduce a 3-dimensional problem to a 2-dimensional problem. Okay. So this plane, if I put it like this, and here, that is the surface. So I want to simplify things like this. Right? That's it of radius r. This is of radius r. Right? And उसका होता रिंग कंसीडर करेगा उसे. This is पूरा R देता है सबसे. सही ना? और this is हम किससे बोलता? This is called Z. This is ना? This is पूरा से this देगा. Right? This is x. No, that was r minus z. Right?
Something
So
like that.
this is z. This whole is r. So this is that equal to r. Right? So we apply chord theorem here. Right? R square is equal to x square plus this square. R square kind of right. So R square is equal to x square plus R minus d whole square should be the whole of your. Sorry? This is equal to x square plus R square minus 2R z plus z square. R square ضرب اتفقنا شو صحيح؟ So x square will be equal to 2rz minus z square. सही है क्या? R खत्म शो x का z बात शो था आप वाला अंदाज
Yes.
Okay, let's ask this question. Okay, I can further write it like this. Z count 2r minus z. That is the equation number. Don't worry. X square equal to z 2r minus z. Right? Now we simplify the area of the whole ring. Like a ring देखा?
Yes, sir.
The area of this ring, when you cut it, like you have an orange, and you cut that place from here, so that the remaining area will be something like
Yes.
this, right? So it will be in the form of a circle. So the area of the disc. This is not a DISC. Okay, so A is equal to 5 and 2x squared. Right then? That is equal to 5 z and 2r minus z and 2r minus z. Where is that is equation number 2. Right? I z 2r minus z is the area of that cut disc. We get it, Molavani?
Yes, sir.
37. That's the whole plug the poor pen cushion. That's orange day, fair day. और जैसे कि माँ काट को ले मतलब है कि that cushion पे माँ काट को तो that area the जैसे area हम हुआ है so that तो काट को
Or that is sure.
और that desk और that area also बराबर है area pi z where z is the this one pi z and z and 2 r minus 2r minus right this is the زي ده زي ما موجود في شو सही का زي ما موجود في شو
Yes, sir.
او r से दे दे radius अब तो कैसे निश्चित यो r दे यो चीज़ है so that is the area after this. Now the volume of the ring, of that ring that you were talking about, right? The volume of that whole disc, you will see. Right? That will be 5x squared, right? And to dz. So you can area is
Yes, sir.
volume. So that will be equal to pi and to z and to 2r minus z and to dz. Number is right? The molecule per unit volume, right? N over VFB is the volume. So that will be, suppose we write it like Gn in the small volume divided by pi z 2r minus z and 2. देखिए जैसे हम molecule मौजूद है. The total molecules in the volume will be d and equal to rho 2 pi rho of z 2r minus z and this is zeta, right? Now look, the here molecules are in the distance of from the surface d plus z,
Yes, sir.
right? Distance between
So, two lists, sir.
distance between right the surface, the plane surface, and the this is equal to so d plus z basically. What's the total interaction world? No die the domestic interaction energy da another two molecules bande
Integrate.
integrate. Right? And that's something because you close pair the part of the world.
This is between. This is between. This is between the. This is between the.
They move on. The total energy, that's the separation. R separation D. K means case between a single molecule and the surface,
Yes, sir.
right? And integrated over all the number of molecules. Say that? Okay. Look, in the previous case, we wrote the final energy was minus 2 pi theta in the case of a single molecule and a surface. However, the total energy was minus 2 pi c rho over n minus 2 n minus 3 d to the power n minus 3. That was the energy between a single molecule
Yes, sir.
and a whole surface. Right? So I can write, I can substitute this energy here. So that will be equal to minus 2 pi c rho, right? And here d n over n minus 2 n minus 3 and g plus z to the power n minus 3. After the answer is 0. So that the separation is d plus z. क्या चीज़ है करा?
Yes, sir.
अरे के separation तुम कैसे value? Z value करा d value. अरे के separation तो d value होती है उस separation चीज़ d plus z है. So therefore we wrote here instead of d I wrote d plus z to the power n minus z. Now further simplifying, like I want to put the volume, the dn here. So that would be minus 2 pi c rho, right, of n minus 2
of n minus 3, right? Now I'm getting rid, I want to get rid of the n. N mungo zeta arrow. So we have a solution. Well, I will write pi delta t or pi delta t, right? Theta and z question and 2r minus z dz. The dn value what? dn value to what you know? We have position integration over dz.
Yes, sir.
Which is dz no n or n baki biasa kapa
Kan.
to transfer to bar.
D plus zero punch.
Here it will be z plus z to the power n minus 3. Sorry?
Rho square होगा ना?
Huh?
Rho square.
What's our name?
Rho square होगी.
Rho square. Yeah, rho square बचेगा. ये वाली कितना rho था मौजूद था.
Yes,
अब हमने निकाला. Right? So that was minus 2 pi square c or rho square like that over n minus 2 n minus 3, right? And this is integration with the sphere. Integration with the sphere. Now you look here. Z is very small as compared with 2r.
Yes, sir.
Sahi. So the square will be very small. That's the answer. No, right? Z square. That was Z square. Z square is very, very smaller than 2r and Z.
Yes, sir.
Therefore, we neglect z as compared with 2r. So this can be simplified here. Delta. Say integration position. Integration position pi. Pi from the draw from
Pi.
so z 2r z 2r z or dz or
D
d
plus
plus
Z.
z to the power n minus 3. Right? And look, z, the limits of z. Z goes from 0 to,
Infinity.
that's right. That's it.
Zero.
So the 0 or the 2r.
0 to R.
Right? So z goes to 0 from 0 to 2r. Right? Okay. Since there is nothing beyond 2r,
Yes, sir.
the contribution from there is 0. Therefore, we can extend 2r to infinity. अब अगर ऐसा नहीं कर करना तो infinity का r ऊपर के पर जाएगा. अब रिजल्ट है ना, there is no contribution, so you can replace
2R by infinity.
2r to by infinity. So I can write minus 2 pi square c rho square, right? Divided by n minus 2 and n minus 3 and 0 to infinity 2RZ dz, and then d plus z to the power n minus 3. Right? I can write this is minus 4R pi square, capital R without part, C or rho square, 0 to infinity, z dz divided by d plus z to the power n minus 2, or divided by here n minus 2 and minus 3. Right? By further evaluation, I can write this in pi square c or rho square r and n minus 2 n minus 3, 1 over n minus 4, n minus 5, and 1 over d to the power n minus 5. सही है, करना ठीक है शुरू। You can get this from the table, right? It's difficult. The table is on page 104. So that is the final equation. The interaction energy. That is the interaction energy between a plane surface and a spherical surface where they are separated by a distance. Look again. The important thing is D and R. R is the radius of the sphere. Greater is the radius of the sphere. Greater will be the interaction. Greater is the density. Greater will be the interaction. Particles zyada working or unit volume, interaction of that. Molecules से ज़्यादा। ये मतलब जो वार्ड molecules है, इतना ज़्यादा बेचारे interaction ज़्यादा।
molecule kan
वाड़ी लो अपन सरा ज़्यादा ज़्यादा जी रो density को ज़्यादा वही number of molecules per unit volume the number density. Third, the interaction is a directly proportional square of the density.
ये पूरी बारी में क्या करेगा?
That is number of particles. It also okay no does चीज़ों ने सूरज ज़्यादा में दशी करना खाना तो सूरज ज़्यादा में दशी खाना no देना ब्याह खबर नहीं जुड़ी और चीज़ अगर इन्होंने चीज़ें हर particles भी आगे बांधने की जरूरी सही ना ताज़ सिमट तो वो रेसुल ताज़ particles तो वो रेसुल सूरज वाला ग्राइंड करी सूरज ज़्यादा नहीं ताज़ रो square नहीं दोनों बताओ सर sticking की You know something? Yes. उस ताज़ दोनों अगर गाना रवाले बड़ा गाना रवाले यो बहुत पूरी मगे आ बस यो दोनों निसी बताओ दा सिमट से जैसे कि खुदा गाना हो रहा कहीं सिमट कैसे खुदा गाना में इधर की right? That is सिमट Okay. No, for n is equal to 6, tungo under master.
Sir, the water has come the way in 60 team of the wall money theory.
Vacuum जोड़े, लकड़ा चलमकी जैसे अब vacuum जोड़े थी सर पल्सर P का ना मुदासी का ना मुदासी vacuum create की ना आगे हो चुका है अभी आगे कोई मतलब
Yes.
Those are the particles, so what are particles? Particles, similar size, micron size particles. Right? Okay. So, for n is equal to 6 van der Waals. Right? Bunun basit direction energy sırası. Lakabın da usma şu van der Waals energy basındaydı. That will be minus I square C, right? C is the force constant between the whatever the type of force is. मगर लाभ का अब कितना है C? van der Waals करने तो C मालूम नहीं करना कितना है?
Yes, sir.
So C rho square R divided by 6D. Right? Now go up. van der Waals today the 3 or the rate of minus today. The separation filling D. Right? The data break, right? If this is constant, this is constant, this is constant, this is constant, and D is the separation. Nutana Sada, van der Waals without D. C is proportional to
1 by D.
1 over D. Yeah, minus 1. Van der Waals force is delta. Look, a molecules की van der Waals force values is
D.
not molecules.
Molecules के सर
Minus
D
1
power.
R to the power 6.
Yes.
Separation to the power 6.
6, yes.
Here is single one power. If there is a spherical particle and there is a planar particle, the van der Waals energy varies as 1 over the separation. And for molecules, it varies as 1 over R to the power 6 minus 6. Right? Because the first one are यहाँ no minus by D machine. मतलब बराबर minus 5 square divided by 6 and C rho square R or 1 over D square. So, biar saya jatuh kisah hak mereka no kisah F proportional to so 6 का 1 over D square था minus 1 over right. आगे molecular surface interaction की यो molecular surface interaction की नाम 1 over D to the power 4.
Yes.
4 is a spherical particle of plane surface, you know, it is D to the power minus 2. So, that पूरा देखना चाहिए था